Hi guys, today we are going to be looking at the solution for the various questions we were given in the previous take home. We are given a couple of questions after we worked on a couple of things on kinematics. So the first question we were given was this: a small metal ball was thrown vertically upward from the top of a tower with an initial velocity of 20 meters per second. If the ball took a total of 6 seconds to reach the ground level, determine the height of the tower, given that gravity, acceleration due to gravity, is 10 meters per second. Now, this question was given to 1991 JAM student. Now, let's look at this. This is what we're going to work on. This is how we're going to go about it. Now, let's assume that there's the tower, and somebody stands on this tower and projects the ball. Somebody standing on the tower and projects the ball into the air from this very, very given point. Now, it was projected with an initial speed of 20 meters per second. Now, there are a couple of things I told you in the previous exposition, and also there are some things I'm going to add to it. Now, the fact is, you're very much aware that whatever goes into the air will not keep going like that. Will surely drop back. So if an object is thrown into the air, it cannot keep flying forever. It will get to a certain height that it will stop flying and start returning back to where it was projected. So that very height it gets to, that it stops flying, or that it stops going with the speed with which it was projected with, that very height is called the maximum height. So at max height, note this, at maximum height, final velocity, that is for acceleration of body along y-axis, is 0 meters per second at max height. So that's what I want to note. So when an object is being projected into the air with any kind of speed, what happens is that that speed with which it's being projected with keeps fighting against gravity. But it gets to a certain level whereby that speed dissipates and becomes 0. So at that very point whereby the speed becomes 0, whereby the body cannot keep flying any further, that very point is called the max height. So at that very point, gravity starts acting on it. So that very object starts returning to where it was thrown from. So at max height, the final velocity is always 0 meters per second. This is just a fact. So for this very stuff, the body was projected with an initial speed of 20 meters per second. So initial speed is 20 meters per second. Now, don't forget the fact we said in the previous exposition that if an object is rising, that is flying against gravity, acceleration due to gravity will be minus. That will be minus gravity, which is minus 10 meters per second squared. That is stated already. That was stated in the previous exposition. So now the first thing we're going to do is that we're going to get two things. We're going to get the time it takes this body to get to this very height. We're going to get that. And I mean the time it took the body to get to this very height, to get the max height, and also the distance it covers at max height. So first of all, you're going to get time. That's the first thing you're going to get. And after that, we're going to get distance also. Don't forget that this distance along y-axis. So when the body was projected, as you can see, a small metal body was thrown vertically upward from the top of the tower with an initial velocity of this. So for the fact that the body was projected, it didn't fly forever. So it got to this very height, and after that, it got to the max height. Gravity started pushing it back. It fell back to the height where it was thrown from and continued falling until it got to the ground level. So that's what we're going to get. So that we are asked to get the height of the tower. So we're going to use this knowledge for the fact that we are very much aware that it flew to a certain level in the air, returned to that place where it was thrown from, and kept on falling until it got to the ground level. So first of all, we're going to get the total time it took it to get to the max height, and the total distance it covered even from where it was thrown from to the max height. That's what we're going to do. So we have these are the parameters we have. We have initial speed. We have the final speed already. This is a fixed value at max height. Then the acceleration due to gravity for the fact that the body flew against gravity, minus 10 meters per second squared. So now with the time is what we're going to get, and the distance it covered. So now we're going to be looking at the equations of motion. That's what we're going to be doing. We're going to be doing that. Now don't forget this along y-axis, acceleration also along y-axis. So time is not along y-axis, time is a scalar quantity. So for us to get the time taken, we can easily use our v equals to u plus at. We can easily use this to get the time it took it to get the max height. So the v, the final velocity, is 0 meters per second. Initial speed, 20 meters per second. Then plus acceleration due to gravity, negative, minus 10 meters per second squared. The time is what we are looking for. So we're going to collect our like terms. This crosses to the other side. 0 meters per second minus 20 meters per second equals to minus 10 meter per second squared times time. So 0 meter per second minus 20 meter per second, that's minus 20 meter per second, equals to minus 10 meter per second squared times time taken. So divide both sides by minus 10 meter per second squared, just like this. We do that, then our time, the time it took the body to get to maximum height is what we're looking for first. That's what we're looking for. So minus 20 m over s divided by minus 10 m over s squared. Can do this over 1 over 1. So minus and minus communicate. We end up getting plus there. So 20 m over s times 1 over 10. This one two changes. Second squared of a meter here. Seconds. We may have ordinary seconds here. Meter cancels meter. 10 year 1, 10 year 2. So the time it took it to get to maximum height, the time it took the body to get to maximum height was 2 seconds. So it took the body 2 seconds to fly from here to here, that's from the top of the tower. That means it's going to take the same body another 2 seconds to fall back to where it was projected from. So that's just that. We've gotten the time it took it to get to maximum height. So let's see the total distance covered for the body to get to maximum height. So what's the total distance? That's what we're about to get now. So we can easily use our v squared equal to u squared plus 2as to get that. So v squared equal to, that's along y-axis, u squared plus 2as. So acceleration, we can use this easily. So the final velocity at max height is 0 squared. Initial speed, which it left with 20 meter per second squared. Per second, I mean raised power 2. Plus 2, acceleration to the gravity minus 10 meter per second squared. Now the total distance is what we are looking for, we don't know. So what was the total distance covered at max height? At maximum height, I mean. So that's 0. That's 0 actually, meter squared per second squared. 20 meters per second, raised power 2 is 400 meters squared per second squared. That's 20 meters per second times 20 meters per second. The plus and minus is minus 20 meters per second squared times distance. Now what do? We're going to collect our like terms. We send this to the other side. 0 meters squared per second squared minus 400 meters squared per second squared equals to, what do we have here? Minus 20 meters per second squared times distance along y-axis, which is also known as height. So what do we have here? That's minus 400 meters squared per second squared equals to minus 20 meters per second squared, then times what we have here, distance along y. So we're going to divide both sides by minus 20. We're going to do that, minus 20 meters per second squared minus 20 meters per second squared. We're doing that right away. So the distance covered will be minus 400 meters squared per second squared divided by minus 20 meter per second squared. That's over 1 over 1. Distance, the minus and minus will give us plus. That's what we have. So that's 400 meters squared over second squared times 1 goes up, 20 comes down, 1 over 20. Second square goes up, meter comes down. So this is just a normal law of division. Second square cancels second square. Meter here 1, meter here, just 1 meter left. 20 here 1, 20 here 20. So that's that. So the distance covered for the body is 20 meters left. So the body covered 20 meters. As you can see, the body flew from this very portion, from here to here. It took it 2 seconds to get to maximum height, and it covered 20 meters during that period. So don't forget the question. The question is, it was said that it took it 6 seconds to cover 6 seconds to hit the ground. So it took it 2 seconds to get to max height, then another 2 seconds to return to where it was projected from. That's 2 seconds. We are very much aware of that. Then it took it another set of seconds, about 2 seconds. Don't forget, it was said that it took a total of 6 seconds for this whole activity to be completed. It took it 6 seconds, as was said there. It said if the ball took a total of 6 seconds to reach the ground level. So it took it 2 seconds to get the maximum height, another 2 seconds to return to where it was projected from. Now, what is left? Another 2 seconds to get back to the ground level. So what we're going to do now is to get the total distance from here, where it was, from this max height, where it fell from, to the very ground level here. So don't forget that at max height, it was 0 meter per second. That's the final velocity. So now we're going to assume that the 0 meter per second becomes the initial word, velour word. So here was 0 meter per second. Now it started falling from this place, down to this place. So at max height, 0 meter per second, that's final velocity. Now that final velocity becomes initial velocity. So what's that going to be? This is what we're going to do. Okay, what we're going to do now, we want to get the height of the tower. So initial velocity along y-axis, this was the former final velocity that became initial, is now 0 meter per second. Now the total time it will take for this to be completed, that will be 2 seconds up, 2 seconds down, that will be 4 seconds altogether. We've seen that already. 4 seconds altogether. Now acceleration, now since the body is falling down, acceleration now becomes plus gravity, which is plus 10 meter per second squared. So what are we looking for? We're going to look for the total distance. So what's going to be the total distance? The best formula we can use here is S along y-axis equal to UT plus half AT squared. That's what we're going to use. So the total distance is what we are looking for now, from that max height down to where it fell, down to where it dropped down to the ground level. So the total distance is this. Initial speed is 0 now, meter per second times time, which is 4 seconds, I beg your pardon, plus 1/2 times gravity plus 10 meter per second squared times time, which is 4 seconds raised power 2. So s equal to ut plus half at squared. So distance along y equals to 0 times 4 seconds plus 1/2 times 2 here 1, 2 in 10 is 5 meter per second squared times 4 seconds raised power 2. So the distance along y is 5 meter per second squared times 16 seconds squared. So 5 times 16 is 80. So the distance is 80 meter. That's what the distance is. That's the total distance it took the body to fall from that very height. There's a height. You can see the height. The distance it took the body to fall from this very height down to the ground level. Don't forget that it took it 20 meters. That is 20 meter was a total distance. The max height it covered. Another 20 meter was covered on its way back. So the total distance from here to here that was covered was 80 meter. So that means the height of the tower will be 80 meter. That will be 80 meter minus the 20 meter. That's the height of the tower. The height of the tower is 80 meters. Height of tower is 80 meter minus 20 meter, which is 60 meter. Okay, here was the second question given to us in our previous exposition, one of the take-homes. So look at this question. A car starts from rest and accelerates uniformly at a rate of 5 meters per second squared. Calculate the magnitude of the velocity after moving through 100 meters. Now this question was given to 2007 NECO student. Now don't forget, this is acceleration along x-axis, unlike the very first one that was acceleration along y-axis. Now this is very simple. A car starts from rest. It was said already that whatever starts from rest, it means initial speed is 0 meter per second. That's the first thing we have to note. So whatever starts from rest, either it is acceleration along x-axis or acceleration along y-axis, as far as rest is being concerned, or as far as it is rest we are talking about, initial speed will be 0 meter per second. Now the acceleration, they said it moves from rest and accelerate uniformly. Constant or uniform acceleration is 5 meter per second squared. So calculate the magnitude of the velocity. So we are asked to get the final velocity. No, for the fact that it moves through 100 meter, the distance is 100 meters. So we are asked to get the final velocity. So these are the parameters. So the best equation of motion that comprises or that's made up of all this all these parameters is simply this: b squared, which is along x-axis, is equal to u squared plus 2as along x-axis. So we are looking for the final speed. So that's that. V squared, initial speed 0 meter per second since the body started from rest, squared, plus 2 times acceleration 5 meter per second squared times the distance which we are looking for along x-axis right there. So what do we have? So what we have right here now is the v, the final velocity which we are looking for, 0 meter per second raised by 2 is 0 meter squared per second squared right here, plus 2 times 5 is 10 meter per second squared times distance along x-axis. So that will be final velocity, this 0 meter squared per second squared plus what we have here, what we have is 10 meter per second squared times the distance. Now, don't forget the distance given to us is 100 meters. That's already stated. It's written there already. I forgot I should have put it in from here. Should I put it in from here? I mean, so this 0 meter squared plus 10 meter per second squared. The distance is 100 meters. That's what we have. So the final, which is this 0 meter squared per second squared, 10 times this, that's 1000 meter squared. This. So what do we have next? The next thing we have is simply this 0 meter squared per second squared plus 100 meter squared per second squared. That is 1000 meter squared per second squared. So that's velocity. That will be square root of 1000 meter squared per second squared plus or minus velocity. So you're going to we can quickly use our table. Taught us already how to get square root of numbers. Take them to 2, just like this. So 3 times 3 is 9. Do that. 3 plus 3 is 6. What will I add here? When I add it here times, I get 100. If I add my 1 and 1, 2 and 2, 2 and 2 that'll be too much. That's add my 1 and 1. That'll be 61. Then I subtract. I'm trying to get the square root. 1 plus this is 62. This 9. This 39. Put my point. Bring my 2 zeros down. So what will I add here? Then when I also add it here, when I times, I will get 3,902. If I add my 2 and 2, if I add my 4 and 4, let me see. 6, 2, 4 times 4. 4 times 4 is 16. 4 times 2 plus 1, 9. 4 times 6, 24. Let me add my 5. 5 times 5, 25. 5 times 3, 10, 12, 6, 31. We are not there yet. Let me add my 6. 6, 2, 6 times 6. 6 times 6, 36. 6 times 2, 12, 15. 6 times 6, 36, 37. I think it's 6. You can't go beyond that. 8 will be bigger than that. So 6 and 6. So square root of 1000 meters squared per second squared. Square root of 1000 is 31.6. The square root of meter squared is meter. Square root of second squared is second. So that's it. So at this very point in time, the very last one, I would love us to still keep trying them. We're going to be working on them, on that very last one, alongside other difficult ones in the next exercise. So if you found this resourceful, please subscribe to this very channel and share this exercise. Thanks. See you in the next exercise.